we've got our second year apprentices, which are very close to preparing for AM2S, but you've just finished AM2. So this ramble is going to be all about those things that you found quite tricky or almost caught you out on your AM2. So let's start off then. Let's start off with us. We're there on a dead installation. You turn up. What's the installation look like to you? Straight
away, first thing, you glance over it at college. First thing, it's a three-phase board.
Okay. So
straight off the bat.
So that means where all the single-phase safe isolation you've practiced, you've now got to be looking at three-phase isolation.
So you go into a three-phase isolation, but three-phase isn't as scary as you think. All you've just got to think is in your board, it's 3 different MCBs. So when you're doing your actual safe isolation and your testing, it's 10 tests. Yeah. So there's that few more tests, and get the practice in. I had a routine where I'd put one of my probes in L1 and then start working my way across. Neutral, earth, then move that probe into L2, all the way along like that, all the way along again. It's just something you get wedged in your head and you think, count them in your head. 1, 2, 3, 4, 5. I'm safe to continue. And that's, apparently a lot of people do fail in safe isolation. For one, they don't put the key in their pocket. They leave their key in their bag or on their cupboard. And you instantly fail safe isolation if that inspector can get your key.
And that's within the first 30 minutes of being there?
Yep.
So from our point of view, so for the learners behind the camera, that 10 stages of testing a three-phase circuit is in the book that you've already been issued with. So let's get practicing now. And Gary does it in a certain order, and I do it in the safest order possible. And remember, when we first start out, we're probing onto the least dangerous conductor, etc. And we've got to get that in our mind. So for us, just remember it's a three-phase disc board, and it was the first thing that you found that was reasonably tricky. We talk about the specification they give you, and you had to wire ring final circuit in singles?
Yep.
Okay, so when I'm thinking singles, I'm thinking, Andrew, all the conductors will be the same side, agreed?
Incorrect.
Okay, so
basically, when you do your induction, you get a pamphlet what tells you a spec of everything. When you go to your drums, like you were at college, you'll look at the drums, and then on the spec, it says in big writing, follow those spec. Normally if you do it in singles, 2.5, 2.5, 2.5. It states CPC 1.5 or 1 mil, and you're like, whoa. Okay. So you start pulling them off, you start wiring it, and all of a sudden, hang on, there's something wrong here. And then you have to rewire it because the CPCs are different. They require you to spec, not what you would do, or because 2.5 better CPC, spec is critical, and they must have said that to me 20 times in the induction. Read spec, read spec, read spec. Because if you don't read that spec and you've done the most perfect install, if that CPC is different, you failed the build. So you've then got to go back and do an 8-hour build again. So the trick there is what they're trying to make you do, I think, because when you got to, and we'll come back to cable sizes again in a minute, when you did the calculations for working out your ring final circuit, remember, little R1, little RN, little R2, you have to record them. We'll probably come back to that when we're talking about verification of results. We'll come back to that piece of information. We know there's a mathematical relationship between 2.5 and 1.5. Do you want to remind us what that is, Andrew? Basically, on your CPC, you multiply it by 1.67.
Good lad, yeah, 1.67.
And once you do that, you'll get the same results as your 2.5, and that's another way of verifying it. Yeah,
so just remember, read the specification, and that was a little bit that's caught people out, could fail it by actually doing a better job by putting the 2.5, and the spec doesn't say that. At college, we wire all our lighting circuits in 1mm squared twin and CPC cables. Tell me what size it was on the spec.
1.5.
And I've known my learners, and this was going back beyond 8 years, we've only just got back the apprentices for 1 year now, that they've actually gone in and wired the lighting circuit in 1 mil because that's what they were doing at college. They felt they were in a college environment, being at a test centre. The specification says 1.5. And of course, we're going to do the 3-plate looping method for our light, is that right?
That's correct.
Or are we going to feed the switch?
Oh, no. Check that again, we do feed the switch. But again, it's what you do in singles, you'd not necessarily do it in twin.
Yeah.
And you do your lighting in twin.
Yep, so you're doing the lighting in twin, and it says, and I know one test centre called it the 2-plate method, and I think I put that out onto Instagram. What they're saying to you is, take the line and neutral to the switch, before then doing 2-way and intermediate. And how many light fittings have we got 2-way and intermediate?
Just one light fitting.
So we've got one light fitting. So in that light fitting, I've only got a switching line, a neutral and a CPC.
That is it.
So that's really key that we feed the switch, and it's in 1.5 cable. But when we come to have to do safe isolation of a single phase circuit, didn't they choose the lighting circuit to be the one?
Yeah.
They did, yeah. So the lighting circuit is completely dead, isn't it? So you never see it live, so you never see a lamp illuminating it at the point you're doing the safe isolation.
Yep.
So that's going to be a little bit different then. How did you do the safe isolation on the lighting circuit that only had a switching line, a neutral and a CPC in it?
And at the end of the day, you're doing your test at the very end of your lighting circuit, but then you're having to use your functionals of your switching.
All right, okay. So elaborate on that then. So I've gone onto the lamp, so I don't know whether it's on or off. I've probed onto line and neutral, but I would have gone neutral then line in the safe order. I've obviously proved my tester first. We know that. We're not trying to tell you how to do these things. We know we're going to have to prove our test equipment, etc., etc. So I've gone neutral and line, and then I've gone CPC in line, and it hasn't illuminated. Is that the safe isolation finished?
No.
What do I have to do next?
You then have to start using your switches to prove. Right, I've got to get it straight now. When you're at your light fitting, you're testing all your, because you'll have two. So
switches. We don't know whether it's on or off at the moment because it was dead anyhow.
You'll have to do basically multiple tests on your functionality of your switches to make sure the test's correct.
So yeah, this thing, I don't say caught me out, but I found it a bit odd. So then you've got to do is operate a switch, because you wouldn't have known when it was on or off. You go back to the light and you do line and neutral, line and CPC. Okay, I would do neutral and CPC myself, so I don't know what the greater mass out there. I'd do all three combinations for gas. Then you operate another switch. Then you do it again. Then you operate another switch and you do it again. That seems counterintuitive in some ways, but that's what the test centre expected. So we test at the light fitting across, I would do all three, and we test it with the switches in each of the positions. And is that what you did? So that was for the safe isolation.
And I actually went overboard. I've probably done it 2 more times because you're just trying to make sure that they see you doing all the tests, because you are watched pretty much all the time.
So just clarify that. For me, we test between line, neutral and CPC, the 3 sets in the fitting itself. Operate switch, do it again, operate switch, do it again, operate switch, do it again. Brilliant. So the people behind me now that you lot can't see you watching this video, and this video is for them, they're all looking stunned at me now. That might have been something that caught them out. Okay, so we're still in the realms of dead testing. Was there anything else, perhaps the insulation resistance test? Is there anything that we've got to be careful or mindful of when we're carrying out our insulation resistance
Obviously
test?
With insulation resistance, obviously you're putting 500 volts DC into the system, so any sensitive equipment like your lamps, your carbon monoxide head, your RCBO on your ring main, and also your DLO starter, because your DLO starter has a little bit of electronics in. You fire 500 volts through that, potentially you're going to damage it. So they are really hot on. So when you've done your dead test, you've already got your lamp out, you've already got your carbon monoxide head off because they get annoyed with the beeping constantly. When you do your insulation resistance and your DLO starter, you do it up to it and then after.
Right, so let's clarify that. So we did the insulation resistance test at the board. All our loads are off. We've left probably our lighting circuit in the on position. However, we'll come back to that in a second. Our insulation resistance test is performed, but only got up to the top of the direct online starter because obviously the start button isn't been energised. You then went to the direct online starter and did you test from below it?
Yes, that's correct.
Okay, so we did the insulation resistance test in 2 halves. Okay, so that's something else to bear in mind. Now, it wasn't that the instructor required you to hold the contactor in by hand. He didn't. So that's the method that we used. Brilliant. So that was a method that AM2 Centre were happy with. Again, it's food for thought on that one. We said about the lighting circuit, the insulation resistance test. You've left it on. Guidance notes 3 suggests how the insulation resistance test should be carried out where there's multiple switches. Is that the way you did it?
Yes, because basically you test it across all multiple switches and your intermediate, because what you want to do on your intermediate is test across your strappers.
So I perform the insulation resistance test maybe doing the whole board circuits. And then I go out into the installation and I operate one of the switches.
I've done all of them again.
So we operate one switch and go back to the board and do the test. We go out again and we operate the next switch, which probably is the intermediate. We do the test again, all 3 remember. And then we go out and we operate the 3rd switch and we do it again. And that's how the video that I've produced on called AM2 and testing lighting circuits is done, where they're doing them one at a time. So they're using guidance notes 3 as their standardised best practice. Is that right? Yeah, really good. So that was some of them, but not all of them. Some of the issues that we had maybe during the dead part of the tests and the processes. We've now energised our circuits. How many of those did you actually carry out live tests on with just the one?
Just the one.
Which test was that you carried out?
That would be your ZE.
So we did our external earth fault loop impedance test. What was the earthing arrangement?
That would have been a TNCS.
And again, was it obvious or was there a plaque there actually telling you what it was? There was a plaque there.
Yeah.
So again, look at the information they give you and then we would be working out our maximum readings. And that's something you have to verify when we talk about verifying our readings.
It is, and also when you're doing your bonding, because obviously there's a calculation for your bonding, it's not on your test sheet, you just tick that it's been verified.
Right.
I did it I just put on the back my actual readings I got from doing my end-to-end test, just because they'd have looked on the back, oh, he's done his bonding.
So we're saying the maximum reading is 0.05 ohms.
5, yep.
Yeah, and we know that, and we're going to do it, and Marcus does it with us, our learners here. He'll record that on the back of the sheet, and that's where we're talking about, and we'll go on about it, verifying your results. So we tick the box in the paperwork to say the bonding is in place.
It's not a necessity, but I did it.
But we put the reading on the back sheet. On that back sheet was the place in which you did the calculation for your ring final circuits, where you recorded the calculations for R1RN and R1R2, and you had to show those calculations.
Yep, and where to find them.
What do you mean by where to find them?
You can either use your on-site guide to verify your things, you can use your regs book, or your guidance notes 3.
Right, brilliant.
But refer to the pages, what you did, and then use your equations on there.
So if for some reason I've got an external fault loop impedance of 0.2 ohms, and I know the maximum is, say, for whichever system I've got, let's say 0.35, I need to tell you the page in the book that I found that result in to verify it.
And also in your test sheet, it will say if it's satisfactory or not.
Okay.
So, or it needs further investigation, because when I went back and done my testing again, it was on a test rig. So a lot of my results were either higher because it's got different paths. Okay. So, it's above, I wrote it on my test sheet, doesn't apply to standards, further investigation is required.
Okay, brilliant. So that's good. So there's only one real life test. So how do I get my circuit impedances, my ZS for each of my circuits, from the measured value? So how did you go about that? Again,
you obviously have your ZE, your R1 plus R2 to get your ZS, and again, you're verifying your results from your paperwork for your books.
Did you do the calculations on a piece of paper?
Yep.
So you had to add ZE to the dead R1 plus R2 value to get our total impedance in circuit, and then did you have to verify that reading?
Yes.
And we can verify that in the 3 books you described.
Indeed.
Now, if I went to the on-site guide and verified my ZS, I take that value. If I went to BS 7671 regulations and took the maximum ZS, can I use that value?
No, because it's a rule of thumb.
It is.
It's 80%.
So we have to look at that reading, find 80% of it, and verify against the 80% reading.
Indeed.
Another point worth bearing in mind, especially when you may be doing the fault finding, where they might have a reading exactly at the one in the regs book. Who knows?
Yes,
and then the 80% drops down. I've got no inside information. No. So that's just something Gary playing devil's advocate. So that's that. So there were some wiring issues. We'll talk about those in a minute. And there's some setup issues. I think you had a nice discussion over lunch when you were talking about setting the motor overload. Now, you didn't have to work out the horsepower.
No.
You didn't have to use the rule of thumb, which is, I think, add a certain percentage onto the value of the current rating of the motor.
Yep.
How did you work out the overload source?
It literally was a simple case of they have about 7 different sizes of motor, and literally right next to it, it now says what you should set it to.
So you've just moved the overload to the reading they gave you?
Yes, so it will say such and such, and it will say set it to 2.1. So you set it to 2.1. Where a big stumbling block was, a certain gentleman in the group didn't know how to set the overload, asked one of the lads, what did you set it to exactly the same, and he had a different motor. So most likely he would have failed on that. But again, read spec, and it will say, use the sheet, and it is in your bay with all of them, and it will say 0.55 kilowatts. There's the overload to set it at.
So it's as simple as setting the number, but unfortunately one of the gentlemen talked about it at dinner, probably set it to the same value as his, and probably failed the assessment.
Probably, I would have thought so.
And there's always a chance that maybe your lighting circuit on your specification might have been in 1mm PVC twin and CPC cables, and everybody else is in 1.5. Who knows?
Who knows?
So again, it goes back, read spec, read spec, read spec.
Yeah, read spec and read it again and read it again.
You had an S-plan heating system, which was pretty much follow the drawing and push the cables in. Wasn't too difficult.
As an old person, paint by numbers like we used to have when we was kids. It is very similar to that. But if you can understand a wiring diagram, just follow it, work out where everything goes, and go from that, because it is all numbered, and the numbers will be there for you.
My students are behind the camera, they'll do the S and Y plan. We've actually got rigs for them to build it on, and Marcus and Matt are really good at that. We might even do a video of that in the future. But again, it's painting by numbers, but there was a trick to it, because I think there was something else connected to that you said also gave you a little bit of time to think.
We had, well, you could either apparently have had an immersion heater or a solar panel. And when I done the install, and luckily I found it at the very end, I put a 3-core in, and literally on the spec, it suggested 4-core, because I thought I need a permanent live there, a neutral there, and a CPC. Lo and behold, I needed apparently a switch live there. So there was a 4-core cable there, and again, this is me just doing it, 3-core, bang, put it in. Realised afterwards, spec, there it is, 4-core. And basically, if I hadn't noticed that, you'd fail the build because your central heating system wouldn't work correct because there wasn't a switch live there.
All right. So we just had a little stop there and a refresh. We think we've got a slight sound issue. Hopefully you've got to this part of the video, and there's a very small tick going on the sound. There's nothing I can do about that. I'd like to think the content that Andrew is passing on to you would be worth you getting over the slight issue on the sound. So we were up to the point where we're saying that our S-plan heating system has now got some solar feeding into it.
Yes, that's
correct. It was
correct.
a 4-core flex, not the 3 that you pulled in. But it was in the specification.
Yes.
The diagram clearly showed it.
Yeah.
So it shouldn't be one of them things we need to worry and research about it.
No.
We just follow the drawing, but follow the drawing as we go through. Right, okay, so we're now maybe at the point where we're looking at the cutout fuse. Perhaps we're trying to verify the amp rating of it, and I think you found a bit of a pinch point there as well.
Yes, obviously you have your main fuse, what comes into your head, so you have to write that down in your verification of your paperwork, but below there, what normally is your main fuse into your house, they had all the spec on there, and what threw me was it was an obsolete fuse.
Oh, right.
And I'm like, obsolete.
So you try and find out the braking capacity of it?
Of an obsolete breaker, and then again you have to either find it.
Was it a breaker or a fuse?
It was a fuse.
It was a fuse, okay,
Yep.
cool.
So it was a fuse on there.
And how did you find the right answer?
I literally had to find it by scrolling through either Guidance Notes 3 or my regs book to find at the very back there is a paperwork what says about obsolete fuses.
And did it give you a BS 88 dash something or other as an
Yes,
equivalent?
yeah.
And the braking capacity was about 16
16kA,
Yeah.
so then you put that on your sheet.
How much time did you waste looking for that?
About 20 minutes.
And you had how long for the assessment?
3.5 hours.
And 20 minutes were tossed away looking away
Yeah.
for that. Oh, that is
really
harsh.
did. And I suppose it would depend on whichever test centre, but that obsolete one was just like, whoa, and I'd never looked for an obsolete fuse ever.
So again, so now we're probably at the point of verifying results. So just a quick one that I found that somebody came out. They said to me when they did their testing their ring final circuit, dead test, there was a fuse connection unit on it. Is that right? A fuse spur, you might call it?
Yes, there was obviously a fuse spur.
And obviously that's got to come off and you've got to probe into that one.
To the top of your fuse spur.
Yeah, just be careful because one lad, because he said it was a ring final circuit, only tested the sockets on the ring and left the fuse connection unit, actually failed it on that, which was a bit of a shame. The college sockets here now, all our circuits have a fuse connection unit in them, so our students don't make that mistake. But again, as you're watching this, let's not miss out that fuse connection unit. We're verifying the results, probably on the back of our test paperwork or on a separate sheet.
It's on the back.
Yeah,
You can have your own separate bit of paper if you find that easier just to write your thing down, but then transfer it to the back of your test paper.
And you said that was something that was really crucial.
Yeah, I think when I was at college, it was looked at, but you didn't have the in-depth knowledge of where to go for in your books, and they were adamant in that on that test paper. Yes, you know how to do it, but where did you get the information? They really want you to know you're using that book correctly and you're finding out these results are correct to what they want, not just, oh, that looks right, that looks right.
So we're not going, I've got a number and it's in there, I'm walking away, which nobody would do in install, would we? We'd look at the number we've got, we'd verify it was within correction, within the BS7671 is the reading within tolerance, and then obviously we'd be going away. But they want you to record that down, page and reference, etc.
Put the equations in, like I can see over there on the board, with R1 plus Rn plus time divided by 4. You need to put that on there, put that equation in, and then put the results you've got into that equation, because they'll just go, oh, no, that's all. But where is your results? You need that results of what you've got and what page you found that in. Okay,
so I think as you're practicing towards your AM2 or AM2S, that's something we should be doing. That people watching out, all the people behind our camera will be doing that anyhow. So do you think that's pretty much covered some of the pinch points? We don't want to give all the gold away, do we?
No,
we're not explaining what the rig looks like. It's a challenge, and it should be a challenge for everybody that does it. But I think we've covered enough of the things that made your life awkward, because I don't believe AM2 or AM2S should be awkward to do because it's awkward rig, things like finding a fuse you didn't know, forgetting to verify your results, and I think that's worth. But we're not telling anyone to carry out these tests, are we? We're not telling anyone, anything that they shouldn't already know. I just think we're helping people overcome that nervous pinch point. Would you recommend doing the pre-day?
Yes, pre-day. Luckily, our AM2 centre done a pre-day, and the college done a pre-day. So if there's anything like S-plan, and also a lot of people have never dealt with a SY proper gland, not a stuffing gland. Yes, I did see your video. So it's little things that when you get your spec paper, I'm not sure about, just give Gary a call.
No. If
there's something you're not 100% sure on, get on it. And
But that's how we came together.
Yeah.
You contacted me on social media, yeah, and we've been, you know, and you had an interaction. You gave me the information you just given to the world, which I think is great of you. And I said, you know, that's fantastic. Thank you very much for your time. And then you're in today, which is great, passing your knowledge on to our apprentices. Andrew, I'd like to thank you for that. That's fantastic.
Thank you.